one of the Apollo mission at the beginning of the 70s was delayed for half of the year. And then they figured out it was like the huge space weather event with the power of 7 zieverts per hour. To give you and the audience examples of what this 7 zieverts per hour is, when Chernobyl power plant exploded, it was only 2.
Wow.
So these brave people would stay there forever.
Did you know that we're now predicting weather in space with AI? Hello and welcome to TechFirst. My name is John Koetsier. Most people may not be aware of it, but space weather exists and it kind of matters. Even if you're never going to get showers or snow out in space, there is another kind of weather. Today, we're chatting with the CEO of a space weather prediction service that impacts billions of dollars of assets, both in space and right here on terra firma. Also has a potential to save lives. His name is Alex, and it's not Alex Poe. His name is Alex Pospeckov, and he's the CEO of Mission Space. Welcome, Alex.
Hello, John. Nice to meet you.
Nice to meet you too. You threw me off there with your LinkedIn and the Alex Poe, but I got it right now. Let's start here. Most people aren't aware of what space weather is, what it looks like, what impacts has. What is weather in space?
So the simple way to describe it, imagine you're traveling in space and then sun emits these invisible bursts of radiation, energy, charged particles, which can be absolutely destructible. This is what we call space weather. And when something like this happens, it affects assets in space, on Earth, and of course, endanger life of astronauts and space tourists.
Exactly. So like if you're in the ISS, the International Space Station, then there'll be a place where you can go as inside as you can get, as protected as you can get, whether the walls have thicker metal or maybe water around or something like that to try and protect from some of those energetic particles, some of that radiation. It's funny because on your website, you list as one of the danger factors is space tourists. I mean, like that's got to be like one of the newest new things, right? I mean, I know it exists and we see it. SpaceX is doing it. We know that Blue Origin is doing it, stuff like that, right? But there's also ground-based installations that are impacted by this. Talk about some of that.
Yeah. So with ISS, they have special room filled with lead, and well, when they have space station, you can have it. It's not luxury. You must have it. But if you're a private space company, I mean, it will cost you a fortune to put this amount of fleet in space. Plus, when you have like 4 people, 3 people on orbit, it's fine. You could always tell them, okay, guys, now it's time to go to this room. And then imagine like in 10 years, we'll have 5, 10, 6 stations. How many people will be live at one moment in the orbit? It will be not so easy to manage safe resources for them.
And ground-based, there have been impacts, right? We've had significant challenges. Talk about some of the significant challenges in the past and what you might be worried about in the future.
So the greatest event for space weather, which happened in the middle of the 19th century, it's called Carrington event by the name of the scientist who found it. The magnitude was so high then in Cuba, you could see solar flares and you could see northern lights. So, and a lot of the telegraph cables, they were burning at this time. So if something big like this will happen tomorrow, then our civilization will be back to 19th century at all, because now we are absolutely interdependent of the electronic communication, of the satellites, of the modern solutions for communications. But devastating events happening, I don't know, like once they're 200 years, 300 years, but more often we see events that affecting us daily. In 1989 in Quebec, one of the transformator was burned due to the geomagnetic storm, and a couple of the million people left without electricity for a week or so, because it's simply, you can't buy it out of the shelf tomorrow, switch off to some backup supplies. In 60s, there is like legend, like in 70s, one of the missile detection systems was activated because of the geomagnetic storm. and we were at the brink of the nuclear war. But then scientists or the people who were in charge figured out, no. It was just space weather event. Everything will be fine. I don't know if it's true or not. This is some kind of the legend. You can find a couple of the articles about it, but you can understand the challenges we have.
So the mechanism here is we've got solar flares or we got coronal mass ejections on the sun, right? And that if that happens and it's focused on us and it's aimed at us, then it's coming our way. And if you're in space, you're largely unprotected by the Earth's magnetic field. If you're on the planet, the Earth's magnetic field typically protects us from those streams of charged particles. But if it's massive, then some of it's getting through is what you're talking about, right? And impacting us. I mean, Cuba, wow, they saw the northern lights, almost the southern lights by the time it's there.
Yeah.
Or Aurora Australis, right?
Yes.
Versus
Australia. Yes,
yeah,
they call it
exactly.
different.
Exactly.
It's interesting that one of the Apollo mission at the beginning of the 70s was delayed for half of the year. And then they figured out it was like the huge space weather event with the power of 7 zilliards per hour. To give you and the audience examples of what the 7 zilliards per hour is, when Chernobyl power plant exploded, it was only 2.
Wow.
So these brave people would stay there forever. And when we speak about these moon settlements, when we speak about circular economy, nobody speaks about radiation. But if you remember, if you've seen the For the All Mankind TV series, the second season, the first series starts with the big solar flare when the astronauts were on the moon. But it's not science fiction. This is how things are really going to happen. Maybe, of course, it was like a bit dramatic, but still, it's reality that we need to face.
And on the moon, I mean, we're not far from having stations or bases on the moon. I've had people on the show who have been building landers for it and also vehicles for it. We know that NASA and SpaceX are working on landing on the moon. The good thing about being on the moon is that you can dig. And if there's going to be something that's going on, you can shield yourself potentially. It's not easy, right? Getting construction equipment, digging, mining equipment isn't easy to get it to the moon, but you can get under 10, 15 meters of regolith on the moon and hopefully be protected, right? Not so much in space. And obviously with a high energy impact on the Earth, really, really challenging. Okay. So you provide space weather projections, predictions. How do you do that? How do you do that?
So now you have a lot of limitations with the current services. So to give you one example, if you're at NOAA or NASA, it's very hard for you to use data from the European Space Agency or the data from non-public sources in your prediction. And vice versa, if you're a European agency, it's very hard for you from the legal point of view to use even public data from the US counterparts. So first of all, we gather a lot of different public and non-public sources. Then we normalize the data in our data lake because you have huge data gaps. Sometimes you could see the data was not uploaded for the last, week or even 2 weeks. Then you can feed your models with data gaps of this size. Then we have our own constellation. We're launching it early next year, which will generate our own sources of data on the low Earth orbit. So we'll have 24 satellites that will be able in the real time predict and provide us with huge amount of data. So we can do from just one set of the sensors, we can do 1,000 measurements per second. So you can imagine amount of data that the whole constellation will generate for us. And the most important thing here that we're also developing in-house our own scientific and machine learning models, because all of the models for space weather data, they were developed at the late 90s, at the beginning of 2000. Of course, there are some exceptions, but generally they were developed 20 years ago. So it's not, you simply can't put machine learning to this thing because you don't have data lake, you don't have unified data, you don't have unified data lakes. So it's still a bit tricky, complicated question. That's the whole system, which with 1,000 times more data than we can have now with our own scientific models, allow us to deliver customers tailor-made mitigation strategies and insights. Because by the end of the day, you as customer, you just don't want to know anything about what's going around the sun. Just want somebody to tell you, okay, what should I do? And what will happen by the end of the day.
So super interesting. Have you already raised the money that you need to ship your satellites into orbit?
Yes, we had our pre-seed round. Now we're finalizing our seed round. So yeah, we have the funding for the constellation for the development, but seed round is still in process.
Okay. So this is, I mean, this is amazing, right? Because rewind 10 years, there's zero chance that a startup like yours can get a seed, pre-seed, maybe even a series A, and boom, we're launching 24 satellites, right? I mean, impossible. You're talking $100,000 a kilo or something like that, right? Now, SpaceX, maybe we're below 10K a kilo. I'm not totally sure where we are, but I mean, it's within the realm of possibility. It's orders of at least one order of magnitude, maybe a couple orders of magnitude cheaper than it was.
Yes, and it's also very important to understand that the miniaturization now allows us to put our sensors to the size of half of the unit. So because my CTO works for NASA space shuttle missions in the middle of 90s. In his days, the size of space weather sensors, I don't know, well, like this. So it was like this huge thing. And it's also possible that now we have, let's say, cheaper access to the orbit and the option to miniaturize our payload as much as we can.
So let's talk about the mechanics of how it works a little bit, because some people might be saying, "Hey, the heck do you know if something comes off the sun? It's here, and you know it when it's here, but how can you predict, right?" So there's a difference in the speed between the speed of light and the speed of these particles that are coming, these charged particles that are coming that are heavy radiation, right? We have, I think it's a couple of days notice in some cases. Is that correct?
Well, now we're going to the very, very interesting question, because what the prediction is. So what's the baseline?
Yeah.
What the accuracy of the usual weather prediction? I think most of our audience was they know there is like no accuracy at all.
Yes, the weatherman's always wrong.
Yeah, I'm 100% sure about it. So something like this happening with the space weather now. So what's the what current system can predict very good if something very big is happening now? The further you go, the lower the power of the event, the least accuracy you can get. But what we do is not about like the direct measurements. It's about complex models that measuring a lot of different parameters, and the second tier parameters, third tier parameters, and then using the data and correlations between these parameters, we can give the forecast. Plus, for example, now you don't have any localization options. So if you go to the NOAA SWPC website for the space weather forecasting, you will see a lot of the indices, G, K. The next question is, okay, is it like 10 in Australia and 0 in the United States, or maybe like it's 10 in Europe? The answer is, it's just 10. So this is the level of localization we have now. And it's a huge problem, because this May, one of the power plants on the northern island of the New Zealand, they switched off their power grids because it was it was alarm about space weather events going to happen. But what they figure out, the solar storm went through, but they turned off the power plant and spent 4 days without full capacity. So it's also the problem about localization and the problem about a lot of the false alarms now you can have from the current systems. Let's say if you calculate properly, in the last 6 years, the accuracy of the midterm forecast was 7.5%.
Ouch.
So yeah, it's public information. Of course, nobody put it in this way. But if you just calculate how many times the official forecast missed and how many times they've done the false alarm, they were able to say if everything is all right, if something is going to be very bad.
Wow. Okay, so I assume you're then also, let's talk about some of these parameters, because that's super interesting to me. I assume you're training some telescopes, or you will be training some telescopes on the sun. You can see an event, you can see a solar flare, you can see a coronal mass ejection, those sorts of things. And then you can sort of, where is it on the sun? Is it going to miss us completely? Is it going to go, is it going to come? Are we going to get the tail end of it? Are we going to get a full hit? Are those some of the parameters you're looking at?
Correct. So we 24 satellites. We'll have 12, let's say, why we need 24 satellites? Like the first question, because we need to have one satellite every hour at the north, at the south pole in cusp to measure what's going on at these points. Plus, when we have satellites on dark and bright side of the Earth, we can see the difference. This is very important. This level of localization allows me to have a real-time map of what's going on. And we're analyzing the differences between all of these parameters in the near real time. So it's not about just, okay, I see the sun, the flare is coming. No, it's not simple. It's not work like this. Sometimes you have a lot of alerts. Sometimes it's missing, but there are a lot of things when results or the impact of the space weather was during the low solar cycle, was when the solar flare was at the very low of its magnitude. So you need to monitor many parameters about it. And it's not about that measuring something in situ. So it's, let's say it's more about analytics and the modeling and less about measurements itself.
Interesting. So super cool. You can tell some level of danger, and then when it's here, you can give specifics about where it's hitting and how intense it is. And so that power plant now could, be prepared to shut down, but not necessarily shut down. Or if they shut down at all, maybe shut down for an hour or a couple hours. And then they hear from you, hey, no, it's fine. It's all good. No worries. You're not in the danger zone. They can get back up, and hundreds of thousands of homes now have power again.
Exactly. That's what's happening, especially with satellite operators, especially when you have critical missions, when you can't switch off your satellite very often, because you really need the capacity of the satellite. Now you're dealing with the result of the space weather event. Something happened, then you need to react. The more precise forecasting you have, the more time in advance you have for the planning. You either can switch off, use the backup system, switch off different radio channels or ground stations. Then you have some level of control of the events that's going to happen.
Yeah. It's interesting from what you said earlier. It sounds like you'll have at least some of your constellation in a polar orbit as opposed to all in an equatorial.
Yeah. Of course, it's like polar orbits.
All of them, or just some?
We have like two different layers. So let's say one of them will be like 450, another one 400, or just a bit more, because we'll have additional layer, so we can see the difference of data between these layers.
Nice.
But I must admit, my engineers, like every week, they're coming with new ideas. That we have new idea for the new pattern. We have new idea for the orbits. We have.
Oh, this is a playground for these guys, right?
Absolutely,
I mean, this is a dream. Yes, exactly. Totally understand. And I guess you've hardened your satellites, or you are hardening your satellites, so that even if there's a serious event, they can continue to function.
We have different approach, so we try to build them as cheap as we can.
Disposable.
Absolutely. So our idea is that we can launch them. If something happened to them, we can launch, not tomorrow because it's not so easy. But let's say for us, we can produce it, in 1 month. Because it's very interesting. Latest European Space Agency gave Airbus and the consortium of UK, maybe some US companies, 500 million for one satellite for space weather that will be launched in 2032 and 2033.
Wow.
My question was, guys, what if something will happen with this one asset? So you already spent 10 years.
Eggs and baskets come to mind.
Yeah.
All of them in one.
Yeah, I can imagine such level, let's say, development when we speak about James Webb Telescope. This is like the pinnacle of the engineering everything that was developed for 15 years. Yeah, fully understand why we need to spend 15 billion for such thing. Then, now you have a lot of different systems. So here we use just totally different approach. Let's do it as cheap as we can, and let's send it as much as we can sensors to space.
Super interesting. It sounds like the European Space Agency and maybe NASA should be partnering with you and shoving you, a couple rounding errors of cash, and as a backup plan, if nothing else, so that there's good space weather forecasting.
Yeah, in US we have US Pro-Swift Act that was adopted 4 years ago, which should stimulate government by space weather data from the commercial companies. It was like
Hmm.
separate act that we
Hmm.
have now here.
Okay. Okay. Very, very cool. Awesome. So let's talk a little bit about your customers. I mean, we've already talked about power plants. We've talked about satellite communications companies. Any aerospace company, frankly. Maybe even airlines. I mean, if you're traveling at, I don't know, 10 kilometers up in the atmosphere, that might matter to you if there's a hardcore. Who else would be a customer for you?
First of all, of course, it's aerospace companies, satellite operators, and space tourists, for example, like private space station companies, because they're fully aware about this problem. But I must admit, not all of them are aware about this problem. I
Wow.
spoke 3 weeks ago with one of the, with the guys from one of these private space station companies, and they said, "Oh, space radiation on the space station, it's the same at the airlines, at the
This is
airplanes."
not comforting.
And
If you are even thinking about putting something in the door, you should know something about this. This is a potentially kill all your customers event.
yeah, absolutely. So sometimes you see just the different level of understanding
Mhm.
about these problems. Airline, of course, last in October and November, Cathay Pacific boarded 3 planes per week because of the geomagnetic storm. Because when you have space weather event, you don't have any radio signal,
Mhm.
and there are a lot of talks from the pilots that told me, well, on the long haul flights during the space weather event, we have a lot of errors in the avionics. But this information is like still secret.
Ooh, that's
But
that's freaky.
yeah, yeah.
Yeah. Yeah.
So airlines fully aware about this problem now. One of our scientific team attended Space Weather Week scientific event this year. It was in Portugal, in Coimbra. And a lot of airlines also attended this event, try to
Mhm.
figure out what can be done together. 3 years ago, 4 years ago, space weather, aviation, guys, are you crazy? It was like this. Now situation is really getting better.
Well,
It's
especially
interesting.
since almost every modern aircraft flies by wire, right? I mean,
Yes.
so yeah, you do not have physical control of your rudder, of your trim or anything, right? And so if your avionics get fried, if other electronics start to get fried, you're in a brick that is flying through the air at a high speed and a high altitude.
With airlines, it's also very interesting. Space Weather Action Group, which was under coordination of scientific office of the White House, they 2 months ago they published their research about different needs of the needs of the space weather users, and they said that in aviation, women pilots, one of the most, let's say, important group, were the most affected by the radiation in space during the first trimesters, during the first weeks of the pregnancy.
Oh,
Nobody
wow.
raising this question,
Yeah. Yeah.
and for them, it's also like nobody answering it. So it's interesting to see how, let's say, new industries and new ways of thinking of the space weather now, because we had a lot of research in the late 80s during the Concorde era. We have a lot of data about the
Mhm.
radiation. Airlines even gave pilots and stewardess the Geiger counters. But what's happened after, like in a month, they said, where we don't know what to do. What should we do? Is it risky? So people were just too much afraid about it, and the project was closed. Now you have like another, let's say another return of
Yeah.
this idea. So
Yeah.
what we should do, what we should do with it. And in May, farmers in the US lost more than 1 billion in losses because all of the modern John Deere equipment and other agriculture equipment equipped with GPS modules,
Ah,
and they're now working in the fully autopilot mode.
yeah.
And then during this storm, they had different coordinates and they worked for a week in the different coordinates.
Oh.
So it, it was unimaginable even like 5 years ago. I'm not speaking about
Mhm.
like 10 years ago. Imagine what else we will have like in the upcoming 15 years.
Yeah, yeah, exactly. As we get more technological, we're more and more vulnerable. Hopefully, we can start to harden some of the key infrastructure. But you know how humans are. We don't often prepare in advance for things. It's too expensive. It's
Oh,
too
yes.
costly. Will it ever happen? Who knows? All that stuff. Excellent, Alex. This has been a ton of fun, and super, super interesting. What's your timeline? When are you gonna launch?
So we have our first, we have first launch in earlier next year. Let's
Hmm.
say until spring we'll do it. Also, we'll have to next launch in fall, and maybe another one by the end of the year. So our idea to launch 24 satellites until 2028. So
Hmm.
I think 2026 will be the year where we'll have the updated product. But every time we're sending something into space and
Sure.
engineers return with more cool
Sure.
ideas,
Yep.
and we'll have the full constellation in, let's say, 4 years.
Okay. Okay. Very, very cool. Super interesting to hear about, and hope it all works out.
Great. It was my pleasure.